Hello and welcome to this Topics in Depth video. I'm Craig Barton and I'm delighted to be joined by my co-host Joe Morgan. Hello Joe, how are you?
Hi Craig, I'm very well, thank you.
That's great to hear. Now we are delighted that this Topics in Depth video is kindly sponsored by our friends at AQA. It's got a little disclaimer to read out here. AQA is not responsible for the content or any third-party material in this video, save for the use of its past examination questions. Now just before I hand over to Joe to figure out what we're going to be talking about today, a reminder that any of the wonderful resources and materials that Joe shares will be available to download wherever you got this video from. So if you're watching along in a department and you want to access these resources, click away and they're all there for you. Right, Joe, 3 questions for you. Are you ready?
Yes.
Question number 1, what is Topics in Depth all about? Question 2, how might a teacher use this video? And question 3, what on earth are we talking about today?
Right, so Topics in Depth is a project I've worked on to support teachers in their teaching by helping them to understand a topic in depth.
Nice.
So that they can teach it in depth. So the idea is that we don't want teachers to scratch the surface of topics and just rush through them. And a way to help them with that is to make sure that before they start teaching a topic, they really understand the curriculum, how it's assessed, what resources are available, how to challenge students. So that's the idea. And we've done a whole series of different topics. And a good way to use them would be in a department meeting, although of course teachers can just watch them on their own and it's good CPD individually. But if a whole department is about to start teaching a certain topic with one year group, then it would be a great idea to devote a department meeting to watching it together and then discussing and looking at the resources together just ahead of teaching that topic. So it's really good preparation for a teacher. Today we have the pleasure of discussing one of the best topics in maths, which is Surds.
Oh, my favourite.
Everyone loves Surds, don't they?
Apart from the kids, but yeah.
Yeah, you're right. They don't. They don't really like it. It definitely. When I did a survey years ago on favourite topics to teach, this was right up there. Yeah, I think this was a semi-finalist. In fact, like really, really popular. But yeah, you're right. I don't think my students like it.
No, okay. Well, maybe we'll discover why as we go through.
Yeah, absolutely. So let's start with. I mean, when I became a teacher and I had worked in banking before I changed career. I thought I'd never heard the word Surd before. Like, okay. I really was like, what is this topic I'm being asked to teach? Because I'm not familiar with that word. I now realise that I definitely would have seen that word at secondary school. There's no way I didn't. But certainly some American teachers or teachers from other countries are like, what is a Surd?
Yeah.
So do you know what the definition of Surd is? Like, how would you describe a Surd?
Oh, remember, you're not allowed to ask me questions.
Oh,
as part of
sorry.
these
I don't want to put you on the spot.
Okay. So an irrational number would be in there somewhere.
Yeah, definitely. Yeah, and so pi is an irrational number.
Yeah.
Is that Surd?
No, it's not.
Right.
So it will be an integer under a square root sign that's the answer's irrational.
So
would that be any good
or
not?
It doesn't have to be square root, but yeah, okay. So
it doesn't have to be square root.
No, a cube root is a Surd. Any root's a Surd, as long as it gives you an irrational answer. Yeah. So
right.
There's like. I think ask any teacher to define Surd and they're gonna struggle with putting it in words.
Yep.
In maths we don't need to put it in words. We can show examples and non-examples. We don't need to put it in words. But there's some really interesting stuff on the definition of Surd. So I'll start with a bit of history.
Okay.
And we'll talk about like how the definition has evolved. And we'll start with the word because it is funny and the students do find it funny. I mean it's a weird word.
Yeah. Rhymes with turd.
Yes, that's the problem, isn't it? I think that's why that's the funny thing about it.
You've got to get over that as well. I mean,
I don't say the word turd in my lesson, but if you do, then yes, I wouldn't say to them that's why it's funny. But there you go. So we have a bit of history. So this is I think the word is perhaps credited to this Arabic mathematician.
I've noticed you're avoiding saying his name here.
You noticed that, didn't you? I'm not going to say his name out loud. I don't like to mispronounce names, but I should have a go, really, shouldn't I? Because so should we say Al Khwarizmi?
Perfect.
So he, fantastic Arabic mathematician who brought lots of maths. In fact, that a lot of our algebra comes from Arabic mathematicians, and in fact, our whole numeral system comes from Arabic mathematicians. So there's a lot of maths that we can. That we bring from this part of the world. But actually, in this case, I'm not saying that Surds come from Arabic mathematicians, but that perhaps is where the derivation of the word came from, because we have the irrational numbers by the ancient Greeks were called, and I don't know pronunciation here, like alogos. And the A at the beginning means not, and then logos means rational or reasonable or like logical, because they thought all numbers were rational, and they really struggled with the idea of an irrational number. If you know anything about Pythagorean history, there's some people got like murdered for thinking that numbers could be irrational. So the Greeks called them kind of numbers without reason, or numbers that were illogical. But the problem is that the word logos, and apologies if I'm pronouncing that incorrectly, but that word had two translations. One translation was rational or logical, but the other translation was it's discourse or conversation, discussion. Okay? So you could translate logos as meaning without words.
Right.
So a mistranslation of that, when the Greeks meant without reason, but I think the Arabic mathematicians thought they meant without words, means that the Arabic started calling it asam, which means deaf, without words, deaf, dumb, or inaudible. And then when the Latin mathematicians translated it from the Arabic mathematicians, the Arabics were using the word for deaf. So the Latin mathematicians used the word for deaf, which is Surds, deaf or mute. So it was never meant to be deaf or mute, but it was meant to be irrational, and it was a mistranslation.
And that's where we, like, when we say something's absurd, is that
Absolutely, yeah. So absurd is it's interesting, isn't it? Because absurd seems to link to the original meaning. They're definitely the same kind of roots.
Really interesting.
But so a lot of people, if you talk about etymology of words or you talk about the history of words, there's always a lot of argument and dispute about them. So if I can just add the word allegedly with all of that, or according to what I've read, because some people will disagree with that. But it seems to be a mistranslation. It was never meant to be without words, but it became without words.
I should say at this point, any complaints to @MathsGem on Twitter, everyone's happy with that.
But yeah, mistranslation of irrational. And we end up with this lovely word, surd, which they don't use in every country. Like I say, they don't use it in America, where they will talk about radicals.
Yeah.
We do use the word radical. We don't necessarily use it in the classroom, but I'll talk about radicals later. Now, interestingly, if you Google surd definition, the top answer is irrational, and that really surprises me. Now, that is... it used to mean irrational, and you can see that from how the word has evolved over time. But and they're saying it's an adjective there. If you describe a word as if you use it as a surd, as an adjective, like a surdic number, you mean an irrational number.
Right, okay.
But then if you look down the bottom where we have the noun is a surd number, especially the irrational root of an integer.
Yes.
But still, so I think are surds irrational numbers? That's not how we use it now. That is kind of an outdated definition, or it's not. That has evolved. And now when we talk about surds, we talk about irrational roots.
Yes, okay.
Okay, so it's a slight change. So definitely in the history of the word surd, it just meant irrational. So now we talk about irrational roots. I love this quote. The word surd is unnecessary and ill-defined. And I'll show you why some people thought this was ill-defined.
Who said that?
I can't remember who said it, because there's a lovely website, and I've talked about this before, because I don't know the URL is something really complicated. It's like Jeff Tripos something. I've told you about this before. And it's a really good site where the writer has analysed the history of maths words.
Oh, yes.
And this quote is from that. So it's worth having a read, and the link is in the links in the
So this is
comments.
big Jeff is saying this.
Yeah, Jeff. No, it's not Jeff that said it. Jeff is quoting someone who said it in history.
Oh, okay.
And the reason it was considered to be ill-defined was because some people thought root 2 was a surd, and I agree with that.
Correct.
Some people said root 6 was a surd, and some people said it wasn't. So some people said root 6 isn't a surd because you can write it as root 2 times root 3, and they are surds. But if you can, so some people said that, but some people said that root E was a surd, and some people said it wasn't, because some people say a surd has to be a rational root of a rational number. So root E is not a surd because that's an irrational root of an irrational number. Now, we don't go into that detail at GCSE level, and I don't know if we really care whether root E is a surd or not a surd, because it's just semantics, isn't it? So does it matter? But that over in history, there's been a lot of debate.
And just to go back to what I was chatting about at the start, are you telling me, like, this is my ignorance, Joe, okay? So cube root of 2, surd.
Yeah.
Is that standard? Does everybody know this? Is this just me missing out?
Knows.
Right, okay, fine, we'll move on.
I don't know. I mean, I'll talk about later how we teach quadratic surds. Like we teach square root surds, but yeah, cube root is definitely a surd. And in fact, we've got some of that coming up in the non-examples and examples. It definitely cube roots do come up.
Okay.
Yeah.
Okay.
But just to show that when I started teaching and I thought I hadn't heard the word surd before, I was totally wrong because it's been there forever. Fibonacci used the word surd to mean a number that has no root. Obviously, that's not right. It does have a root. It's just irrational.
Wasn't the brightest.
And Robert Record used the word surd in his very famous textbook, The Pathway to Knowledge, which is one of the first sort of English language maths textbooks. So that word has been in use for a long time.
Nice.
I don't like this is from a modern GCSE textbook, and it shows that there's sometimes the sort of rigor that goes into the definition of these is missing, because if you look at that, surds are roots of rational numbers. Now, if you say it's a root of a rational number, then that means that, yep, root 2 is a surd, but it also means root 8 is a surd and root 4 is a surd, and root 4 is not a surd. You know, so you can't say it's the root of a rational number.
I mean, we talk about this all the time, right? This is why any kind of definition is problematic.
Yeah, definitely.
You need the examples and non-examples, otherwise you're screwed.
Absolutely. So, yeah, I think in a way there's possibly no point in trying to have a worded definition of this. But I think if I would add the word irrational there, a surd is an irrational root of a rational number, and that's kind of the definition that I would settle on. So surds are irrational roots.
I mean, I'm obsessed with definitions, right?
Yeah.
So your problem, I mean, with that definition is to understand it. You've got to know what rational is. You've got to know what irrational is. You've got to know what number means.
Yes.
And when you're having to define the definition, you might as well give up at that stage.
Yeah, it's too complex. So that's why. No, this isn't examples and non-examples so much as this
That's
is
better though.
This is surd or not a surd. But look, we've got those cube roots and fifth roots in there, so you can see that they are classifying them.
Okay.
But yeah, I like the bit at the bottom, which confirms what I've just been saying. This is from Maths is Fun, which is a great website. In fact, surd used to be used for irrational, but now it's used for a roots at irrational. So that's just confirming what I've been saying about how that word has changed over time. Surds have a decimal which goes on forever without repeating and are irrational numbers. Now, when our students are meeting these, they will already know what irrational is because they have been introduced to pi. Pi and surds are the only irrational numbers they see before A level. Obviously, when they get to A level, they're seeing E as well. But
you get the maverick teachers chuck a bit of tau in, don't they? You know, sometimes.
Yeah, you're right. They do. I don't do that, but yes, you're right. But sometimes when I was teaching pi to my year 8s quite recently, some of them asked for could I give them examples of other irrational numbers? Because at that point I'd only shown them pi, and so I said, well, root 2, and we're gonna explore that, or not just root 2, but I said we're going to explore that when we get to key stage 4. But it was nice that they were asking.
Yeah, of course.
There's this interest in different types of numbers. And then they might say, what other types of numbers are there? And you can talk about, imaginary numbers. So like types of numbers is like a really interesting thing to talk to a class about. Lovely. It blows their mind a bit, but it's worth doing. But yeah, this kind of, you can see on this table, it's that helping you to understand what's a surd and what's not a surd. On Maths is Fun, they conclude that when it's a root and it's irrational, it is a surd. But we must remember that not all roots are surds.
Good. Yeah,
so
good.
root 4 is not a surd. Boss Maths has great non-example example sections on it. It's always helpful. And you can see, again, we've got those cube roots and fourth roots there. So, yes, they are surds. And on the right, we have some integers, some fractions. They're not surds. And then we have some roots that give you integer answers or have integer values. I would probably just pop a pi on that side because just to clarify that, yes, it can be irrational, but still not a surd.
Yeah, and you might pop. Yeah, tricky. You might pop, and this is like it will be kicking off here, Joe. But you might pop like a ninth, root of a ninth, just to show that rational. Well, yeah, just to have. You want some more boundary examples in there.
Yeah, so they've got the root of a quarter down the bottom there.
Yeah,
which is the same kind of idea, isn't it? So,
I
because I think when I've shown this to my class before, they've said, what's going on with that?
Yeah,
and I said, well, if we write it as a fraction, but at that point they don't know they can root the top and root the bottom, or it's not even that though, is it? Because it's not root the top and root the bottom. It's saying what can I square to get this number?
Yes.
And
Well, I'll say one more thing because you know I love this as well. Right? So we talked about this in a previous Topics in Depth. You know my classic. I say classic. That's a bad thing to say about your own thing, right? But when
classic one day, definitely. We'll talk about it in years to come.
When I split a mini whiteboard up into 4,
Yeah.
and also surds is a great one for this, right? So you say top left, give me an example of a surd.
Yeah.
Top right, give me another example of a surd. Bottom left, give me the most interesting example of a surd you can get. And bottom right, give me an example of something somebody might think is a surd, but you know it isn't. And you could imagine those bottom left and bottom right, they're going to be great discussion points.
Yeah.
Because the kids are going to be
Absolutely.
either side of the boundary.
Yeah, so I think for my interesting example, I might do a cube root.
Yeah, good.
And then
which
for
I
my
fall for.
yeah,
That's
and
good.
then for my one that people might think is a third that isn't, that's where I'll probably put a fraction under
Yeah,
it. But
I agree.
I could probably
That's
be more
nice.
creative than that. But that's
good.
like my initial thoughts from a student's point of view. That's
Yep,
what I'm
good.
doing. Nice. Yes or no? Is this a third quick exercise? I've done that before. It's cold calling the class.
Yeah, good.
And like there's some nice examples in there. 2 root 1, for example.
That's
you know,
good,
root 1
that's
is,
good.
and actually at that point they might they might not know what it means to have the 2 in front. It means 2 multiplied by that
course.
number. I always talk about the parallels with algebra and how 2x means 2 multiplied by x, so 2 root 9 means 2 multiplied by root 9, and because often there's some misconceptions there, and I often talk about parallels of algebra. When you're simplifying, it's just like algebra. When you're expanding brackets, it's just like algebra. So making those parallels between things they already know is helpful.
And again, just on this, we've spoken about this in previous ones as well, where like something like this is so important to do in isolation before you start doing any surd simplification, any surd operations, because unless they're secure with this, you then try and build something something new on top of something they're not secure with anyway, and it's just all going to collapse. So the 5 minutes you spend on this is 5 minutes well spent.
Also a great opportunity to develop oracy. One thing I typically don't do very well is I would say, right, pick someone. So Josie, what is root 4 a surd? She'll say no. And then I'll say, why not? She'll say, because root 4 is, she might just say, she must say, because root 4 equals to 2. Whereas what I want her to say is, root 4 is not a surd because the square root of 4 is a rational number. So like that full sentence and forcing them to say it, or insisting on it, is how we develop oracy, and it's what I don't do very well.
2 reasons for that, that I've been thinking about. So one is to develop the oracy, which again then will translate to written communication. But the other important reason is, imagine, so you say to Josie is, what example did you pick there?
A root 4.
Root 4. So you say to Josie, is root 4 a surd? Josie says no, you say why, and she just says because it's an integer or whatever.
Yeah.
If Ben is in the class and Ben hasn't been fully concentrating, but just tunes into Josie's answer, all he hears is because root 4 is 2. Whereas if Josie gives the full sentence, then the kids almost have 2 opportunities to connect the knowledge together. It's sentences, full sentences in maths. The more I see it in action, the more I'm obsessed with this.
I agree. This one's from Dr. Austin, and it's similar to that one we saw on Maths is Fun.
She's good, hey, as well.
I'm using her resources loads. This is where they do for themselves, discover what's a surd and not a surd. So at this point, you don't necessarily don't necessarily have to say, well, if it's a square number under the square root sign, I'll give you. So they'll just, thing is, there's not many here that are answered. It's only root 1, root 4, root 9, and root 16, and the rest of them are just given these long decimals to write out. But a good way of reinforcing what it means, the definition. So nice activity. What's the connection with a radish?
Oh, jeez.
It's a nice picture of a radish. I like
radish, rabbit. No, go on. go on.
Well, a radish is a certain type of vegetable.
Root.
It's a root vegetable.
Nice.
Radish comes from the word root, because it's a root vegetable. In the same way, radical means root.
Okay, nice. Yeah.
So they both come from radix, from Latin meaning root.
Radish. That's good.
And radical is a word that I don't tend to use in my teaching, and in America they would use it as a standard in this topic. The other day I had a further maths year 11 student who was trying to explain something, and it was to do with domain and range or something, and he was trying to explain something in his answer, and he wanted to use a word for the number under the square root sign, and he asked me, and he said, Miss, what do you call that?
Good
and I
question.
said, I was like, that's a radicand. And I said, you know what, most people don't know that. I was really proud of myself that I knew the answer to his question, because I know these words, but most teachers wouldn't necessarily know that, and that's fine, because we're not using those. But the whole thing is a radical. And then you've got the radicand is the number underneath the root sign. The root sign is called a radical symbol, and then the little number is the index.
Let me ask you this, right? So, again, back to my ignorance at the start, where I didn't know that cube roots were surds. Yeah. So what are you saying there? Are you saying, like, do you have to say, like, quadratic surd, cubic surd, and is it the same with radicals? Would you describe that as like a cubic radical or something like that?
I mean, it's not language we tend to use, but officially that is it's quadratic surd, cubic surd, and then
Wow.
here. But then you'd say like fourth root, wouldn't you? You wouldn't.
Yeah,
We haven't got.
okay.
But we don't tend to use those
I like
terms.
that radicand. I'm
Yeah,
gonna chuck that in.
the radicand. Yeah,
That's
so
good.
you could say if the radicand is a square number, then it is it's rational. Like it's,
Good.
but I don't tend to say that. It's just nice to know.
Yep.
And again, a lot of these things, it's good for maths teachers to know them. Doesn't mean they have to use them in the classroom.
No.
It's just subject knowledge.
It's lovely that.
The radical symbol. Now, this is one that's controversial. Some people disagree with this, but Euler suggested that it was a letter R, and that's where that symbol came from. You know, it's a radical sign, and it looks like an R. Do you think it looks like an R?
No.
Well, it
Not
doesn't
having
there, but perhaps when you handwrite it in old-fashioned quill, it looks like a. So that some people say that's not where the sign came from, but some people say that it was you write an R, then you write the number to mean
okay.
the radical of this. You know, so
Yeah,
I don't
yeah.
know, but so that might not be true.
It's good that though.
Descartes added the vinculum because if you don't have the vinculum over the top, sometimes students say. Because if you're using equation editor when you're making a slide or a Word document or something, it doesn't. Sometimes it won't have the vinculum on it, so it might just say root 2 without a vinculum on the top, and that's fine. But if I say to them, if you had something like root 5x plus 8, then you need to show that that plus 8 is. If you don't have the vinculum, then it's just root 5x.
You're chucking the word vinculum around like it's the most normal word in the world here, right? You mean it like the horizontal?
There you go. The line across the top.
Nice,
yeah.
Okay.
So that shows it's a grouping. It shows that whole thing is being rooted, and in that case, not just the 6y. So the vinculum is essential there. If you were just writing root 2, the vinculum isn't essential. But I have had students put up their hand and said, why haven't you put John a line across the top? And it's a good question. This tells us that you've got the index, the radical sign, the radicand, and the vinculum. And then also see at the bottom it says if no index is shown, it's presumed to be 2, and that's something I teach students in year 7 when we do roots.
Yeah.
Third root is called the cubed root, or I call it cube root, and then it's just fourth root, fifth root.
Do you know what? And this might be the most obvious thing you've ever heard in your life, but this is just dawned on me now, right? Would that be the only instance where if nothing was shown, you'd assume it wasn't 1? Like everything else, like if it's X, we assume it's 1.
You're right.
Is this like we all say the invisible 1? Is this the only case of the invisible 2?
You're right, because the root, it's not the first root, it's a square root, and it's the invisible 2.
It's weird that, isn't it?
Maybe I never thought of it. I mean, I always tell students in year 7 when we introduce them to roots, I always say, you know, if there's no number there, it's a square root. But I've never realised before that it's the only time it's an invisible 2. Yeah, interesting. Do you recognise where I've taken that screenshot from? It's such a lovely website, that definition.
No, I don't.
So there's a website called A Maths Dictionary for Kids, and it's been around forever. I mean, it looks like quite a dated website, but it's so lovely. I use it for loads of definitions. So if people want nice definitions for their lessons, that is a great place to go.
Good.
It's just
American. English, I assume.
No, Australian, I think. Yeah,
okay.
it's very mathematically rigorous as well. Like
Nice.
this is someone who has good subject knowledge, so it's really nice. Right, I want to mention a few things from old textbooks.
Oh, of course.
Things that have fallen out of use. So we no longer talk about the order of a surd necessarily. Some people might, but the order of a surd, like three. I was going to say 3 root 10 there, which is actually a common misconception. So we don't write 3 root 10 because that means 3 multiplied by the square root of 10, and that's actually a common calculator mistake.
Yeah, of course.
When students want to enter a cube root, sometimes they just type the number 3 and then do the square root, and that's something to really draw their attention to.
Yep.
So sorry, the cube root of 10 is a surd of the 3rd order, and then obviously we've got the square root of 10.
Got it.
Is the square root of 3 is a quadratic surd, but we don't use that anymore.
Okay.
We also don't talk about surdic expressions, but we should because that sounds great.
Good. No, I like that.
I sometimes say that in lessons just because it's just a nice thing to say, surdic expression. Someone told me that sounds a bit Scandinavian. I don't really know why. Surdic, nice word. And then root 18 is an entire surd, which means not in simplest form. Now, if we still use that, it's actually really helpful vocabulary, but we just don't use it.
It's a shame.
Like I could say, write 3 root 2 as an entire surd.
Yeah.
Like,
we could bring that back.
Well, I haven't had much luck with changing maths vocabulary.
Okay.
Who tried to do that? Robert Record tried to do that in the 1500s. He tried to change maths vocabulary and failed.
He didn't have YouTube.
Yeah.
So maybe.
Well, maybe I could go on TikTok, like new vocabulary. Right, so curriculum-wise, there's no roots in primary school at all, and I think that surprises some teachers.
Wow.
Some teachers just assume that year sixes have seen
Really?
roots. It's not mentioned. Doesn't mean they
Oh,
won't see
okay.
it. Like I know that my daughter has seen square root sign, but I know it's not on her curriculum, so that's just a
Yeah,
bit of
okay.
challenge or a bit of extra
Yep.
stuff. They have to know squaring and cubing, but then they haven't seen powers beyond power of 4. So when our students get to us in year 7, and for us it's when we introduce algebra, which we do pretty early on, there's a whole lesson on squaring and cubing and and like what does it mean to have a power of 5. We do a whole load of work on that, and then we also do as a significant chunk of time on what roots are, and we mustn't assume that they just know the square root of 49 is 7 because they haven't seen that before.
And as you always say, we certainly mustn't assume they can bang it in the calculator.
Yeah, and actually, there's a really nice activity on Teach It Maths, which has got, it's a crossword or a cross number, where it's calculator skills for roots and indices. And so what I normally do is, because it doesn't necessarily take a whole lesson to teach them what a square root sign is. So I normally do a lesson where it's like, right, this is what a square root sign is, this is what a cube root sign is, and now let's look at how to do it on a calculator. I give them this lovely cross number, and it's got quite a lot of challenging stuff. It's like find the cube root of it, and it's like a 6-digit number, and it's just calculator skills, and it's really lovely task.
You could bang a link into that.
Yeah, definitely. I do that every year, and it's normally one of the first calculator lessons they have in year 7. It's really nice.
Because it is worth emphasising, and correct me if I'm wrong, calculator is not mandatory at primary at all. There's a decent chance year 7s will come in and
never seen a calculator. Yeah. That's definitely something that changed in the curriculum, and so they are so excited about using calculators. It's incredibly engaging for them, and also so important when they get to GCSE with the 2 calculator papers that they've been using them for 5 years.
Yes.
It's interesting when you look at the curriculum. It kind of says students shouldn't be reliant on calculators, and it's almost like it's the Key Stage 4 curriculum is a bit down on calculators with that little introduction there, but we know how important they are, particularly at A-level, so we should use them consistently from year 7. At Key Stage 3, we do have the word root used, so they do have to be introduced to roots, and most people do that in year 7. So they extend their understanding of the number system to include roots, and they distinguish between exact representations of roots and their decimal approximations. But that doesn't mean teach surds. It doesn't mean teach simplifying surds at Key Stage 3 and all those kind of things. That comes at Key Stage 4. I know some schools will do it earlier, but it's definitely not on the Key Stage 3 curriculum to simplify a surd. When we get to GCSE, that's when our surds come in. The dark content then is higher tier only. So, of course, we have surds is definitely only on the higher tier. Simplifying surds, see it says surd expressions. They mean surdic expressions if they're using like the original language involving squares. So that's why you've not seen the cube root as a surd before, because it's not on the curriculum.
Yeah, this one I'm going wrong.
And then they give an example there of simplifying root 12 and rationalising denominators. And notice how they don't mention things like expanding brackets, but that just comes under simplifying surds, so they don't have to explicitly mention it. And of course, you've got estimate. I mean, that one at the top there, estimate powers and roots of a given positive number. That's something that some people struggle to teach a bit. So, can we estimate the square root of 63? That's actually slightly easy. That was a bad example because that's just less than 8. There's and also fractional indices involve surds sometimes. I suppose it normally involves rational roots. A-level, there's nothing new for surds, although we know they use them throughout. It does say use and manipulate surds, including rationalise and denominator. That would have to be a show that question at A-level because they do have calculators now. Obviously, those of us that used to teach the old C1, surds was huge, and a lot of students struggled with their fractions and surds, and it meant that they found the whole paper difficult. But also you've got the proof that root 2 is irrational, and that's the big new surd thing they have to do at A-level. It just comes under that big chunk of work on proof. We have, and also I suppose, in further maths, they've got roots of negative numbers.
Of course.
So there is some new root stuff happening at A-level as well. But the majority of what we're teaching at secondary is on Key Stage 4 and comes up at GCSE. At my school, it's one of the things we start year 10 with surds and indices. I find it quite a nice topic to start with.
Yes.
I actually changed my mind about that a bit. If you start year 10 with a whole load of topics that are only on the higher tier, and then you decide at, say, Christmas, that you might have accidentally put someone on foundation, they should have been higher, they've missed a whole load of higher only stuff, and it's quite hard for them to catch up. So I'm actually not sure it's the best strategy to put a load of stuff that's only on higher at the beginning of year 10. But
just two things to add to this curriculum thing. So the first
Yeah.
thing is, the thing we always say in these topics in depth is that it's really useful for all teachers when they're teaching a topic to know what's come before it and where this topic's going.
Oh, definitely,
So before
yeah.
you launch into year 10, Surds or whatever, really important to have a sense of where kids have come from in primary, key stage 3.
Yeah.
And even if you don't teach A-level, to have an awareness like this
Yeah.
of where they're going to meet it.
Yeah.
And secondly, I'm going to go controversial. Every now and again, we like to go controversial on topic in depth.
Yeah.
I'd say you would be mad to teach Surds at Key Stage 3 when there's too much Key Stage 3 content
Yeah.
anyway. And as we know, teachers struggle to go deep
Yeah,
into
yeah, yeah.
it. So
Yeah.
of all the things to leave for Key Stage 4, you've got to for Surds, haven't
Yeah,
you?
absolutely. And the thing is, well, you often get, say, in a grammar school where the students are really coming in very advanced on the primary stuff. That's where you might see these things being taught at Key Stage 3. I still argue that there's plenty of challenge and
course there
depth in
is.
the Key
Of
Stage
course
3
there is.
curriculum. But the only thing about having Surds come up, so we do it at the start of year 10, and then quite soon into that, we're then doing exact trig values, but they're not particularly secure on Surds at that point because they haven't seen it much. So actually there's some argument for saying the two places that Surds really come up. I mean, I suppose Surds comes up all over the place because you've got it in Pythagoras as well. It's quite a lot of places. But yeah, we found this, that when we were doing exact trig values, which we did sort of just about a month after we did Surds, they'd kind of already forgotten the Surds. So it's something that you have to do a lot of retrieval constantly on it. And it was interesting. I teach AQA further maths to a year 11 class, and we only have an hour a week after school at the moment. And I had assumed a strong knowledge of Surds because they're all working at a grade 9. And actually, when I gave them some quite tricky Surds questions, they weren't secure on it. So that is one of those things where, because it's not introduced till Key Stage 4, they're not quite as fluent in it as they would be if they had met it younger. But I'm not saying do it at Key Stage 3 because, like you say, not enough time. Some examples of exam questions. So this is AQA's GCSE maths typical example.
Nice.
You've got the simplifying, you've got rationalising there. So rationalising with that root 50. You could multiply that by root 50 over root 50, or you could simplify it first
Tough
and then
question,
rationalise.
that. Tough.
Yeah, it's a 4-mark question, so there's quite a lot to do there. Question 24 is near the end of the paper. This is the stuff that's considered to be for the the sort of grade 8, grade 9 students. This was 2019 in November, where we know we don't get many higher tier entrants, but not well answered. Look at this. Oh, it's painful. They took root 18 to be 9 and root 50 to be 25. Like that's upsetting to read.
That approximate value is an interesting one, though, right? Like 7.1's a funny one.
They gave them approximate values such as 4.5. So I wonder where are they coming up with that? Is it a calculator paper like that? I don't know.
Weird though, isn't it?
That is weird. That is weird. Yes,
Good question,
I agree.
though. That's a good question.
Yeah, but not done particularly well. And then that top one.
That's good.
The top one proved challenging. We haven't got part B on there, but in part A it says many students failed to convert to a mixed number. Sorry, the mixed number into an improper fraction. Because if you do that, you're getting 49 over 4.
Yeah.
Which actually, this isn't even a third question. This is a root question. And then the next one doesn't look, not a traditional third question. It's an exact trig values question, but really that is a third question as well. So we've got a lot going on with roots.
Yes.
But notice still in the latter part of the paper, a lot going on with roots, and obviously all in the non-calculator paper here. So if you look at that second one, they used one correct trig value but didn't process them correctly. And there's interesting things they do here. Like, for example, 2 sine 45. A lot of students think that's the same as sine 90. Like, they just don't know what that 2's. They don't know what it is. Like, they've got no idea what's going on.
Well, again, the point we always make in these topics in depth as well about this is that obviously when kids take the GCSE, they're going to meet questions they've never seen before, like combos they've never seen before. But it's still important to expose students to past exam questions like this whilst they're doing the topic, just so they get familiar with combining different things and they're prepared for weirdness. If you're not prepared for weirdness, you're going to be in a bit of trouble.
And also, if you look in that one, if you look at the wording of it, the second one, give your answer in the form where A, B, and C are integers, which suggests you might need to rationalise because you've got an integer in the denominator. Like the exam questions have so many different kind of words, command words in them that they need to have seen a lot of these things before. this one is always interesting. Give this one to a group of maths teachers and see what they do with it. Simplify the brackets first is by far the quickest way. That
it's
if
not your instinct though, is it? Maybe?
Yeah, because you see the you're squaring and you think double brackets, but that inside the bracket, what is that? 5 root 3 minus 2 root 3.
Yeah.
So you're literally just squaring 3 root 3, which is
nice.
very quick. But I think the majority of students and perhaps even a lot of teachers would double brackets that. And it says it was a good discriminator. When I say it's a good discriminator, they normally mean that only the very best students got that right. So it's really picking out those grade 9 students. Most success was obtained from expanding the brackets without simplifying first, but it was quite well attempted. And if they didn't show their method, 0 marks. So it's a good example of, it's a show that question. So show your method. And it's unusual. Show that question that doesn't give you the actual answer at the end. Show that normally says what you're aiming for. And then another one where we have a mixed number under a root sign, so turn it into an improper fraction first, and then again some general surd work there. It's a lot. It's quite hard adding, and there's some rationalising. There's no rationalising there, but there might
these are good to do for teachers before they teach the topic
definitely.
as well.
Just to teachers have to be 100% confident with these. Definitely. This one again discriminated well. Many were able to convert root 80 to 4 root 5, so they're getting marks even if they can just simplify. So if you're teaching like a borderline class, like for example, my class of students working at a grade 4, they might not be able to get 3 marks on that question. They can certainly get a mark on that question, and that mark makes all the difference. They can simplify root 80 even if they find the rest of it tricky.
Nice.
I just want to show that also this does come up on further maths, on AQA's certificate of further maths, which is such a wonderful qualification.
Massive fan of it.
And that question there is, simplify everything, rationalise. It works out. The questions on these assessments are really lovely. They normally have like a nice, satisfying answer. But it's a good place to go if you're looking for a challenging Surds question, if you've got a really strong class. The other thing is, I should mention with just rationalising. On certificate further maths, you have to rationalise when there's a binomial at the bottom. So say, for example, 2 plus root 3 in the denominator. And you rationalise that by multiplying by the conjugate, which is, so if it was 2 plus root 3 at the bottom, you'd multiply by 2 minus root 3 over 2 minus root 3. Now, I thought that was on GCSE, but in AQA's teaching guidance, it says actually...
I thought that was GCSE.
Yeah, and I don't know about other awarding bodies, but I know that if you look in AQA's teaching guidance, they have added clarification to it to say that you only have to rationalise with a single term at the bottom. I mean, it might be something like 5 root 3, and the students need to know that the efficient way of doing that is to multiply by root 3 over root 3. They don't need to have the 5 in there. But it won't be a binomial. It won't be 2 terms at the bottom. So we had already... Last year, we taught that to our 10s, not realising. And then actually that was helpful for the ones that then went off and did certificate of further maths, because they do have to rationalise using a conjugate there. But certainly I this year did not teach rationalising using a conjugate, because I realised that actually that's not on GCSE.
It's worth saying at this point, and again, although we're sponsored by AQA, we're under no obligation to say this. We both love that level 2 certificate of further maths.
Wow, it's my favourite lesson of the week. Yeah.
And there's loads of different ways to teach it in schools.
Yeah.
Some do it as like an after-school club. Some do it alongside GCSE and so on. How do you do it?
So at the moment, it's the first time we've done it, because I've got year 11 for the first time in my school, and I'm doing it 1 hour a week after school.
Nice, yeah.
It is a little bit rushed. Sometimes I'm losing lessons when they're in mocks and stuff, and so it's a little bit rushed, particularly when I found that some of their underlying knowledge, like I just assumed they could do Surds when they couldn't. And also it's interesting, like I'm doing things like 2 lessons on increasing and decreasing functions and stationary points, so calculus. Well, I might spend a week or 2 on that at A-level. So it's like, this is really, I'm saying to them, like, I'm doing this so much quicker than I would at A-level. But they're, the brightest kids. It's okay. But next year we'll do the same. But the year after, we're doing it in an option block. But you can't stretch that over 2 years. So I'm doing GCSE statistics in year 10.
Oh, okay.
And then they do AQA further maths in year 11.
Nice.
So that means that the very best mathematicians who love maths will choose it as an option block. And then they do that as a 2-year course, 2.5 hours a week on the timetable.
Cool.
But it's great. You know what someone said to me, he said, you know how all we're doing in this course is geometry, calculus and algebra? He said, what about the stuff you get on GCSE, like those long problem solving questions with ratio and fractions, and like someone works in a shop and like work out the profit? And I said, no, none of that here. This is all beautiful maths. It is just like, this is like the maths that your A-level mathematicians will go off and do, and it's just fantastic. So they love it. Right, so just have a think about the prerequisites for
Okay.
teaching Surds. So things they have to know. We need to understand what an irrational number is, and they would have met pi before, so they should understand that. If not, you need to explain what an irrational number is. They need to know. I say index laws is an interesting one because perhaps they can do Surds without index laws, perhaps. But I like there's links to square root of a power of a half, and there's also it depends how you teach it. Because I'll show you in a minute, there's two ways of simplifying Surds, and one involves perhaps using indices. So we'll get to that.
All right, good teaser there.
The way I teach it, my students need to know their square numbers fluently.
Okay,
but linking to what I just said, some people need to know prime factorization. So we have two different ways of doing it.
Gee, you're really keeping the viewers hooked in here, Joe. Like it.
They need to know roots. So what's the square root? You need to understand that. I say basic algebra. They need to know how to add and multiply terms.
Yes.
Because it's the same idea. They need to understand what simplifying means. They need to know how to expand brackets because a lot of that comes up in Surds.
Of course.
And they need to know equivalent fractions and understand if you multiply by root 3 over root 3, you're multiplying by 1 and you're not changing the value.
Yes.
There's maybe other things that I've missed there, but there's quite a lot that you have to have done at Key Stage 3 in order to do it.
As well as equivalent fractions, like all their fraction operations are probably going to come into play.
Yes, absolutely, yeah.
It's good that.
And the thing is that all of this is Key Stage 3 stuff, which means when you get to Key Stage 4, you're ready to teach Surds. Just in terms of old textbook
what
again.
year are we going
I actually
back
don't
to?
know, but from the font, I'm going to say it's probably 50s or 60s.
Okay.
It's an exercise where I look at this and I think, I should do more of this because
they're good,
you could do this when you introduce roots. This isn't Surds, this is just roots. You could do it when you introduce roots in year 7 with like a top set year 7.
Yeah.
No reason they can't do this if you're doing roots. Like no one can say, my year 7 class, I just told them what a square root was and moved on because they're so smart. Give them this and that will challenge them.
Oh, cool.
But also a nice recap on roots before you start Surds, so it could fit in anywhere.
We've talked about this before, that this obviously it's important kids can do this without a calculator, but you want them to have the calculator next to them to check, and then you get the best of both worlds.
That's a brilliant idea.
You get in the calculator fluency, the building up. You've got a self-checking mechanism in there. They're probably going to enter the negative number in the wrong place. They're going to get math error on their calculator, and then they're going to get an answer.
Yeah,
and it's
perfect.
Just,
that's a great use of this. So get them to do the task without a calculator. Calculator's out to check it. Go around and circulate and help with people who are struggling with their calculator.
It's nice.
But there's some nice things there because and this leads into discussions about notice how there's no square roots of negatives there and why would that be? But we can cube root a negative. Things like I would say if I'm going to do the cube root of negative 0.001, I'd write that as a fraction. There's a whole load of interesting skills here, but it's not Surds. It is just. I mean, look at that. The fifth root of negative 32 over 243.
And even like question 4, I and J. They're getting a bit hard then when you get in the powers and the.
No, you're right.
Love that.
So there's in terms of skills that you then teach during Surds. You've got the definition first of all, so that we talked about examples, non-examples. Then I, at that point, move on to simplifying, but that is in 2 directions. So not just taking root 18 and writing 3 root 2, but also taking root, and that's the bit most people miss, turning a 3 root 2 into a root 18. Multiplying, so, and that multiplying includes root 3 times root 3. And it's so interesting when you see the students expanding a bracket and they have to do root 3 times root 3. And I want them to know that's root 3 squared, and square rooting and squaring are the inverse, so you just get 3. But quite a lot of them there might write root 3 times root 3 is root 9, which equals 3. And it's interesting, they need to understand that square root of 3 squared is 3.
With that 4 root 3 all squared, anything could happen with that, You can imagine any answer.
Well, some of them will see that as, they'll get confused with double brackets there.
It'll be all kicking off.
And the thing is, you could write it double brackets, but they're going to see it as they're going to think it's going to come out with 4 terms and then you simplify. There's all sorts of things, But that is, you do have to keep track. If you're going to do that in your head, it's like keeping track, isn't it? It's the 4 squared gives you the 16, and you hold that in your head, and then you say, well, the root 3 squared is 3. Multiply those together. It's definitely a case for getting that on paper.
Correct.
Yeah. Adding. So adding So I would start with, right, if I have a 1 root 2 and I add 3 root 2s, I have got 4 root 2s. And that's kind of how I say it. In the same way, I might say, right, if I have 1x and I add 3 x's, I've got 4 x's. So they have to understand that idea of, adding like terms and the not correspondence, but how similar it is to algebra. Yeah. But also then they need to know that root 18 plus root 98, the classic mistake there is they just add the two numbers. Of course they do. But they need to simplify first. So that's the challenge.
They'll also need a few non-examples there of things that can't be simplified by adding and so on.
Absolutely, yeah.
Love it.
Expanding, so we're getting onto high level challenge here, single and double brackets. And then finally rationalising, and that's where I said, like, that second example there is one that isn't on AQA GCSE. Not to say that you shouldn't do it if you've got a really good class, but yeah, the first example. And I tell you what they find hard with rationalising is often the simplifying at the end, because they do that dodgy thing where they cross out things that aren't factors, So
and also that they're cognitively knackered at that point as well, right?
Yeah. They do the rationalising, and then it's like, right, I can see a load of 3s and 6s here, and I don't know what I'm allowed to cross out. And they cross out under the root, and so they do that. And then, of course, all of that, then some problem solving and bringing in some other interweaving with other topics.
Yes, love it.
Just one point that's so key. They need to know that 2 root 3 is double root 3. They need to know there's a root 3 and a root 3 there. It's a coefficient that confuses them. Like, you see students who teaches them a whole load of like stuff where they've written 2 root 3 on the board and they just don't know what it is. They're like, what? They have no understanding of, they're just seeing it on the board and they're not understanding this root 3 is a number, and we can approximate it, and then we're multiplying it by 2.
Yeah, and contrasting that with the root 6 is not double root 3. Do you know what I mean?
Yeah, absolutely.
It is a minefield for kids, right? It is a
difficult topic. Yeah, definitely. And then common mistakes. So I see students who write root 18 is root 9 root 2, which I'm happy with.
Good,
Yep. And then they turn that into root 18 as root 3 root 2. Good. So they're not understanding that root 3 is the same as, the root 9 is the same as the root 9 is the same as 3. It is not the same as root 3. They know root 9 is not root 3, but yet they write that a lot. Another thing I see students doing is that, where they say root 18, they say, 9 times 2, and then they just don't write that root sign. Like, these are really, really common mistakes. And I didn't ever expect to see them at first. And then after you've been teaching a while, you're like, I'm going to see this a lot. The students are going to not know. Because that's when they're following a procedure and they don't know what they're like. I know I need to write a root here. I know I need to write down some factors. They don't really know what they're doing. So these are really common mistakes. That's an old textbook, clearly. I'm going to. This is 1800s by the font of it. Express. This is what I was talking about, going backwards.
Jeez, look at some of those.
Oh yeah, I mean, like, we never put algebra under. Like, we don't call them surds necessarily. There's some crazy stuff going on there. I'd struggle with some of that.
Look at that P bombing. Look at 29 with that flipping P bombing around on the root. What is that?
The P fruit.
Jeez.
But I don't think I'd do this with a class, but that first line of questions there, like 18, 19, it just makes me think I don't ever get them to convert backwards. It's a really, really worth doing.
What was this, like a year 5 textbook back in the day or something? That is unbelievable.
Yeah, look at that. So 4 11ths over root 77 over 8. I haven't tried these questions.
I can't do half of those, I'll tell
you.
I
assume that they come out with nice, interesting answers. But there's definitely a case for working backwards. If they know how to simplify, then they should be able to unsimplify.
Good God, Joe. All right, let's have some easier, please.
This is a bit more modern, and this is just like Google Images comes up all sorts of nice things. And I just quite like this because, like, root 2 times root 2 times
nice.
8.
Yeah, okay.
And the thing is, you could multiply. So there's 2 different ways, isn't there? You could multiply in that first one 2 by 2 by 8.
Yep.
And then simplify.
Yes.
Or you could say, right, root 2 times root 2 is 2, and then you could simplify the 8. There's like some interesting methods there, and it takes you on to a lovely bit of problem solving like that. Yeah. Now that looks like a killer, but I love this.
I like that.
I could do this. That. I could just sit doing questions like this all day.
And
Isn't
again,
it nice?
we speak about this in previous topics in depth. Anytime there's more than one different way to get the same answer to a problem, it is just brilliant for discussion.
I've given this question, slightly cruel of me to give it in an end of unit test, and a lot of students just multiplied all the numbers together and then simplified. And then obviously I'm like, well, hold on, you've got a root 1 there. and then we've got a root 4 and we've got a root 9.
save
So
yourself a bit of
and then some of these can be combined. Like I've got root 2, root 5, that's root 10. Like, and then I've got a root 10 times root 10, which is 10. Like, it's lovely. I mean, there's like some workings on it, and it comes out with 720 root 7. So root 7's the only one there you can't pair up.
That's great, that.
Yeah, nice question.
Great question.
Yeah. This is Boss Maths, and this is where, like the old textbook one, that we've got some letters under surds, like under roots, and I think yeah, again, not necessarily surds because they're not irrational. Like, I don't know, I don't think I would call this surds. They're just roots. But interesting, you know, to understand that b squared square rooted is b, such an important thing for them to understand.
Yeah, it's good, that.
So some good stuff from Boss Maths.
Good Boss Maths.
Oh, definitely, yeah, loads of good stuff on there. Right, so here's our 2 methods that I talked about earlier.
All right, okay, go on then.
Right, so you tell me which one that you
All right,
do.
let me just get my head around this. Yeah, okay, yeah.
Yeah, so they have to know the square numbers.
Squares, yeah. That's my method. Right, what's this? Oh.
So you wouldn't do it that way?
No.
So the reason some people do it the way with the primes is because they think students just can't spot the square numbers.
Yeah,
and actually, to be
point.
fair, you look at root 48, a lot of them would have chosen 4 as the square number that goes into it.
Yeah, I can see that.
Normally when I'm first teaching it, particularly with a weaker class, I'll put write the square numbers on the board, and then it'll help them pick square numbers.
Yeah.
I'll tell you which one they struggle with. Say something like root 98. I know in like a millisecond that is like 98 is 2 times 49, but they're not spotting that. Like,
which one are you? You're not the one on the right here, right?
No, I'm old school. Yeah. But I considered trying. You know, when I discovered the product of primes one, I really thought that's like great, and then I thought about teaching it, and I thought, no, I just want to stick with the old-fashioned way of doing it. But yeah, I do know that. I know a lot of teachers use that. If you look on Dr. Austin, she has 2 sheets on simplifying. One that uses the first method and one that uses the second method. So this is something that some teachers are doing. Great to practice prime factorization. And also great for understanding, because when you have done the prime factorization, you can say, well, what have I got there? Well, I've got the square root of 2 squared, which is 2, and then I've got another one, and I don't know. I am not convinced that it's got advantages over spotting the square numbers, but I do appreciate that not everyone can spot root 98.
Well, let me ask you this. I mean, some people call you the queen of methods, don't they?
Good.
I've heard it said.
I am the queen of methods. Yeah.
So obviously you have a book, Mathematical Methods,
yes, I do.
Available now. What's your approach here? So you've got a preference of a method. Most teachers would have a preference of a method for doing something.
Yeah.
Are you teaching the kids one way, getting them familiar with that, and then saying, oh, by the way, there's another way, let me show you, as a kind of as an interest or an alternate thing? Or are you teaching the methods side by side?
In this case, I only teach the one I've taken out the square number. I don't teach the prime one, but in some topics I do. I taught quadratic sequences last year. I put a slide up that said there are multiple methods, because I've written the book on it. There are multiple methods for finding the epitomic quadratic sequence, and today I will show you 2, and you will pick your preference. I showed them the residual method, I showed them a formula method, and interestingly, half the class picked one, half the class picked the other.
And just to drill down a bit more of that, you show the method, because this applies to lots of topics, right? Show the method 1, practice method 1, show the method 2, practice method 2, then pick? Or... Yeah,
and then I give them just an exercise, and I say, right, and then on the screen where the task is on the board, I've got the steps and example for each method, and I say, right, so just to not confuse them. But I don't do that particularly often. I normally pick a preference that I've got. I think it confuses them sometimes. But also sometimes I'll show them a method and then they'll go onto an online platform like Hegarty Maths and it will do a different method. And then I think, oh, I wish I'd shown them the same one. So sometimes I think it's nice to show them 2 different ways of doing it, but not if it's going to confuse them. And often it does confuse them. For example, I was doing sharing in a ratio last week, and I said, it was with year 8, and they'd done a bit of it in year 7, and they might have done a bit of primary, and I said, I'm going to just put up 3 different ways of doing it. Because and I also want you to know there's other ways. So I showed them like a bar model method. I showed them like a little table method, which is how I set it out. And I showed them the sort of old fashioned, if you're trying to split in the ratio 3 to 2, you just divide by 5. And then I said, so if you already have a preference and you're comfortable with one, I'm happy for you to use it. Because a lot of them, like, so for example, sometimes tutors will teach them a different method and they'll already, but I said, but all my modelling, I'm going to use my little table layout. So then I consistently stick with that. But then when I set them a task, I say, There's an example on the board with the way I do it, but I don't mind if you choose a different method if you have one that you prefer. So, but then I will be consistent with my modelling.
Got it.
Yeah.
Love it.
But yeah, with this one, I stick to the spot a square
Yeah,
number.
yeah.
I tell you, these aren't surds. This is from Halings. But look how lovely this task is. So break each of these numbers into its prime factors to find the square root. Now, I can't find the square root of 1,764,
that's
but if I
good.
do the prime factorisation of it, I can. And this really links to that second method there. This is something that might be nice to do in year 7. Once you've done prime factorisation and once you've done roots, what a lovely task. Hey, look, we can find roots of really big numbers if we know how to prime factorise.
Yeah, you see, I'm contradicting myself here because I'm obsessed with prime factorisation in terms of then when you see it, does this tell you it's a square number, a cube number,
exactly,
related factors? But yeah, there's just something about using it for surds that's just not. But I love this. I think
it's nice because because here everything pairs up, and if it didn't pair up, then it wouldn't be a square number. So it is really nice. But yeah, this is classic Halings, like really in depth, lovely tasks in there. I don't know. Do you know the book Nixer Tricks?
I do know the book.
Yeah, I remember this was quite a long time ago. Like I think maybe sort of 7 years ago, maybe this came out.
Yep.
If teachers aren't familiar with it, it's a free download and it's a brilliant book. A lot of the tricks that they are saying teachers shouldn't use are things that are common in America, but not so much in this country. In fact, when you read it, you realise that American teaching, certainly 7, 8 years ago, there was a lot more tricks than we were using in England because most of them, I read it and I don't think teachers in England do this stuff. So this one was called, this is what they're telling you not to do, jailbreak radicals, or you need a partner to go to the party. So this is what they would call the method.
Right.
And they say the radical sign is a prison. And in this case, you've got root 18. So you prime factorise it. So you get 3 times 3 times 2. And you say, well, the 3s are going to pair up to break out the prison. But only one of them survives the escape. So you get 1 3 on the outside and the 2's still in prison because it couldn't pair up. Like,
it's tenuous for a start, isn't it? Right?
Oh, it's so painful, isn't it?
And you can imagine this is your classic kids getting focused on the surface because you know what's going to happen there. What happened to the other 3? Did he die? Did this? You can see it coming straight away, right?
Yeah, it's bad, isn't it? So I don't think we have that. That's not something that's commonly taught.
That's not needed.
Oh no, I mean, there's literally zero understanding there.
That is horrendous.
And it's overly complex, and I don't know what that is. In the book, they suggest this geometrical approach, and I do know some teachers have started trying to teach it this way.
Yes.
I think some of these approaches that try to teach deep understanding just overcomplicate things. So I don't use this. I did consider using it, but they're sort of they're saying if we're trying to do the square root of 18, then we need a square with area 18. Because we're trying to find the side length.
Yeah.
I really think that, I know some teachers have found good ways of explaining it. I think that some of these deep conceptual explanations I think some of them are just a bit too complicated.
Yeah, we've spoke about this before and I've written about this. The problem with this, I mean, again, we should say this is like a legal disclaimer. Of course, both of us and all teachers want kids to understand why things work. Of course we do, right? But the problem with something like this is, like, understanding that is harder than actually doing the calculation, right?
Yeah.
And we've all taught kids for whom spending 5 minutes trying to explain this and they're like, what the hell are you going on about?
Yeah.
And then you've lost them.
Yeah,
because they're in their head, they hate surds.
And they hate maths because it's just so there's definitely there's a place for it maybe, and I know some teachers have a lot of success with this, but I decided not for me.
Yeah, fine.
Just with rationalising, there has been a lot of debate, particularly in the States, about what's the point in rationalising. Now, the point in rationalising comes from historic reasons before calculators. So look at this. If you want to find the, say, 6 over root 2.
Yep.
Now, you could do 6 divided by root 2. Now, it used to be that they always gave decimal answers. In any third question, they would then write an equals and a decimal. And they had tables that told them. So they'd know what root 2 is, what root 3 is. And then they would always, so say an answer to a question was 2 root 3, they would multiply 2 by the decimal of root 3. And they always gave answers in decimals. They might work in surds in the calculation, but then answer in decimals. And here, if they want to do 6 divided by root 2, they have to do 6 divided by root 2. We're not doing that with like a bus stop method, are we? Like, that's horrible. So it's much easier if they rationalise, and then they're doing 3 multiplied by root 2, which is something they can do.
And again, that takes 10 seconds to tell our current year 10s, and it just provides a bit of interest, a bit of historical background, and crucially a bit of a purpose to why we're doing what we're doing.
But also the argument then for this, and why this is not helpful, is that we don't now convert them to decimals, and if we wanted to do 6 divided by root 2, obviously we'd use a calculator. So now we do it because it's interesting and it's a math skill and it develops our mathematical understanding of what surds are and how they work.
Correct. And then I just say, shut up and get out of my classroom if they're asking stuff
stop
like
asking
that.
me questions.
Exactly.
But it's interesting. They used to say in old textbooks, results in surds are only practically useful when expressed as decimals. So they used to say, you have to turn it into a decimal, or what's the point in it? But now we say we don't need a point in it, and that's nice. I like that.
Literally don't need a point.
Literally.
Oh, pun.
I don't even realise how funny I am. I made a pun. Okay, good. Right, and then this is old textbook, 1800s, 1885 in fact. And this this is rationalising, but I tell you what's nice about this. I'm not suggesting anyone uses this activity,
Right,
but I just want they see the first 10 questions.
Yep.
Not rationalising a denominator, but multiplying conjugates.
Yeah, good. Yeah, good.
So we've got 9 root 2 minus 7 times 9 root 2 plus root 7, and they're practising that skill. They should all give rational answers because they're all conjugates. And then only when we get down to see question 11 with that division sign, it's quite unusual to have it, we normally write as a fraction, then they're actually starting to rationalise. And it made me realise that before I teach, if I was going to be teaching rationalising with binomials at the denominator, I really should start with, let's practice multiplying double brackets with where the...
Well, it goes back to what we were saying before. It's your classic atomization.
Yeah.
We talked about it with recognising what is a surd and what isn't.
Yeah.
Before you go anywhere near rationalising, you want the kids to be fluent and confident with multiplying those. Identifying the conjugate and then multiplying them out. 28's pretty
I was just looking at the 28. Well, with 28, my first thought is I'm going to simplify the denominator first.
Yeah, I think so.
Because if you simplify that, the first 2 are in root 3. What's root 32? I'm trying to do maths in my head here. Yeah, it's going to be a binomial when you simplify it.
Yeah, I think so. Yeah, 2s and 3s, isn't it?
I mean, anyone that says they can't challenge their top set year 10, there's plenty of challenge.
Of course there is.
But you do have to look at 1885 to find it. Just to mention some command words in different exams, and so you get the word rationalise used.
Yes.
But you also get questions which don't use the word rationalise.
Yes,
so like bottom left, it just says work out and give your answer simplest form. So simplest form does mean a rational denominator.
Yeah.
And then, or you just get told the form they want it written in. So yeah, we're not always going to see the word rationalise.
See, simplest form's an interesting one, right? Because it goes back to that previous argument. That's vague, isn't it? Simplest form.
Yes, it is.
Because you've got to understand the interpretation of what simplest form means, whereas it's a lot. It removes all the ambiguity.
Yeah. I'll tell you another example where it's not like simplest form. Say they got something like 5x plus 10 as an answer in an algebraic fraction question, and the answer of whether they can answer 5 brackets x plus 2, and whether that is which is simplest form, the factorised one or the non-factorised one. Does it matter? It doesn't matter. So the writing what form they want it in does give clarification.
Yep.
Just one more on rationalising, because I love this.
I like this one.
And the thing is that this is, again, you got a class who have just worked really quickly through surds, then given some really fun puzzles. I love the way it's just and so on up to.
It's good. That's a
but a load of rationalising, and this just is a beautiful question and really works out well. I've written interleaving there because actually these slides are old. I think can I rephrase that to interweaving?
Of course you can.
Yeah.
Of course you can.
So we're interweaving with some other topics. Pythagoras, surds come up a lot because your hypotenuse is often a surd that then needs to be simplified.
Yep.
So we're seeing surds in that topic. We can see surds in area questions as well. We can see surds that come up in quadratics, particularly when using, say, the quadratic formula. If we were doing that without a calculator, we might end up with a answer that's a surd. Geometric sequences, multiplying by a surd every time, or there's some great questions on that, real good level of challenge there. Exact trig values, all involving surds, and as we saw earlier, AQA often have questions that involve things like sine 60 and then doing some simplifying with that. Circle geometry, so sometimes we're seeing surds come up with the radius of a circle, for example.
Of course, yep.
And proof, but again, that is A level. You're getting the surd stuff coming up in proof. But yeah, all sorts of places that a good knowledge of surds is necessary.
Are you annoyed you've not been able to think of one more?
Well, I wanted my little link symbol there, so yeah, that was. I'm sure that was intentional.
Fine.
But here's I didn't have this on there. Averages.
Oh yes.
This is like a question I use almost every single year that I've ever taught, and I like it because it's stuff they know really well, mean and median.
It's beautiful, that.
Yeah, but
It's
to find the mean, obviously they need to add them together, so they need to know how to add surds. So simplify them first, add them together. But then to find the median, again, they have to have simplified them, and then it really falls out very easily what the median is. But there's more on that. Nathan Day, and he has interwovenmaths.com. This whole exercise is on mean, median, and range.
It's great, that.
And using sets of surds. And look at all the challenge in there and all sorts of things going on.
You've got negatives chucked in the mix. You've got even data sets to find the median.
It's nice, isn't it?
It's good. It's good.
Lots of opportunity for interweaving. This was what I was talking about, irrational sequences. This is from MathsPad.
Oh, I've not seen that one.
Oh, it's so nice. I did this last week when I was doing sequences with year 11.
That is good.
That's a nice way, because actually I was doing sequences of year 11 and I wanted to recap some key stage 3 sequences. And I said, well, you know what an arithmetic and a geometric sequence is, and now you've learnt surds, because some of these are geometric. If you look at that first one, multiplied by root 2 every time. Look at the second one, I think we're multiplying by 2 root 3.
Right, okay.
But in that third one, what have we got there? Root 2, 2 root 2, 3 root 2, 4 root 2. We're adding root 2 every time, so that one's arithmetic. And these are lovely build-up and challenge.
I'm going to say the most obvious thing in the world, Joe, but I'm saying it more for my benefit. With all these resources, the teacher has got to have done them themselves as a mathematician first. Because there's a danger, you get a bit cocky like me, you look at that and think, oh, that's nice, I'll give that to the kids. And then the kids get stuck on D or whatever, and you're like, what the hell is going on?
You need to know what you're doing with this,
Just so you know where the sticking points are going to be, so you're more confident delivering it. It's something I didn't do enough of.
Yes, and also so you know whether you've taught the right stuff in advance. Like you don't want to say, I'm doing a lesson on sequences with year 8 and put this on the board, because they have to have surds for this. So you definitely need to.
I'll tell you when I've been
do a bit
out,
of practice.
Used a bit of Frosty, bit of Dr. Frost. I've banged one of his PowerPoints on. And he has his little skull and crossbones questions, and that's come on the board, and the kids have looked at it and said, we can't do that, so I've looked at it, so well, I can't do it either, and it's been a bit embarrassing for everybody.
You don't want to get put on the spot when you're a teacher. It's difficult, isn't it? Well, let's have a look at a few more resources.
Of course we will.
So this is standards unit, classic, old school, always good. This is true or false. I normally used to use this. There's a similar thing by Susan Wall on STEM Centre that I used to use at A level, was just an introduction, just make sure they really understand surds. We all know that a lot of students think that root 9 plus root 4 is root 13. You can so easily show why it's not. If you say, well, we all know what root 9 is, it's 3, and we know root 4, and 3 plus 2 does not equal root 13. So it's quite easy to show why it's not. But there's a nice level of challenge there, and even look at those 3 at the top right, all false.
It's clever, that. And again, it goes back to what we were saying before, get the kids to do this on their own first, and then instead of putting the answers up, check it on your calculator.
Good idea.
Lovely. It's just lovely. Love
that. This is from Chris Baker, who has made a lovely task. It was on variationtheory.com. And I like this one in terms of when because it's that real chunking the topic down into very small, atomization. We're multiplying surds, and I want them to know that root 2 times root 2 is the same thing as root 2 squared, but they might start by saying, well, that's root 4, which equals 2. Rather than the way the way it's written top left and the way it's written top right. On the top right, they're more likely to think, well, the squaring is the inverse of rooting. Whereas on the left, they perhaps will write root 4. Don't know.
And the thing with that, again, we say this all the time, Joe, that's going to take, 5 minutes max in the lesson? But it's a really worthwhile, because you want the kids to look at root 5 times root 5 and give it no attention whatsoever, because they just know it's 5. Versus if they don't know that, and it's mixed in with some other multiplying concept, they're screwed.
I'm actually seeing, I saw a lot of my students, like I said, they're working at a grade 4, my current year 10s, and we did surds, and we did the whole lot of surds, but I am seeing them do things like, in an expanding brackets question, they're writing root 5 times root 5 is root 25, and then they're just leaving it like that. I want them to just instantly know that that's 5. I'd mentioned Dr. Austin earlier.
Classic.
This is what I was saying about the 2 different methods. So on the left, we've got the take out a square number. So
otherwise known as the correct method.
Largest square number factor, which, like I said, sometimes they struggle to find. And I always say, if you don't find the largest, you can still get to the right answer. If you've got root 32 and you take out a 4, you can get there, but you're not finished on the first step. And then split into 2 surds, rationalise the square number. It's interesting she used the word rationalise there. I normally use, I'd say find the value of it, but it's quite nice to use rationalise. And then there's your answer. And then her second resource is write them as a product of primes.
Interesting.
Simplify the repeated surds, and then there's your answer. Yeah, so it's nice that she's got the two different approaches
fair play,
there.
fair play.
Yeah. This is one I made, but it's just we use.
Did you make resources?
No, sometimes I'll make the odd slide. From
Right, okay,
so
yeah.
You can see this is one of mine because
It's
see
good,
that little task thing at the top. We have whole cross-school icons that we use in every single
What
lesson.
does that mean?
It means that it's a task for them to do on their own.
Why is there 2 wheels? What's the
Because
significance?
I don't know, they're thinking. I don't know. I didn't make the icons. They're good. We have an icon for challenge, and we have an icon for write down, like take notes, and we use them across the school and everything.
Okay,
particularly useful for SEND students as signposts, so they know what they're meant to be doing.
I'll let you off.
Yeah, I don't know about that.
Tell you what, resource is good though.
So I've got the square numbers there for scaffolding.
Yeah, nice.
And then the idea here is it's structured so it should give them a starting point. They're meant to be breaking it down into 2 surds, and then they're meant to be simplifying the first one. But then notice how the challenge is built into the task.
I do.
Because near the end you're then going
lovely,
backwards.
that, Joe. You should do more of this.
Thank you. The thing is with the going backwards at the end is there's the challenge. And interestingly, we had a maths teacher in my team recently was observed by a non-maths teacher.
I can already predict what's going to happen here.
And the feedback said that there wasn't a challenge task in the lesson. And the teacher, talking to me afterwards, said, but he's used the Dr. Austin resource and they all have inbuilt challenge. Right. So, and this is another example where I don't need a separate challenge task on the board because the task has inbuilt challenge. It's not all just the same stuff. And like, you can't spot that if you're not a maths specialist.
You can't. And just, well...
I'll
get myself in trouble.
Yeah, it's a real flaw of being observed by a non-specialist. Yeah. They can't see that we are doing the right things. We are challenging our students. We don't need it sort of specifically signposted and separate.
Correct.
And actually having it built into the task means everyone's doing it. What I would have had with this task is I probably had a little handout or something. So anyone that finished it really quickly, I might have given them a little challenge thing as well. But I would have made sure every student in the class got to the end of this, and then everyone's getting the challenge.
Yeah,
you can't have it so that some students only do the first 4 questions and never get onto the harder stuff.
I'll tell you, I'm going to go off on one just very briefly. I mean, you're right about non-subject specialists observing. I think there's useful things that can come from that, kind of generic things like mass participation, checking for understanding, all that I think is useful. As soon as you start getting into challenge and stuff, I think, like I wouldn't have a clue about challenging a history lesson.
Yeah, absolutely.
Blah, 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 blah. But the other thing I wanted to say, just about kind of extension tests and differentiation. So I interviewed Sammy Kempner on my Tips for Teachers podcast, available on all podcast stores. Great podcast. And he's massive into group work.
Right.
And he's got a mantra, and I've adopted this now. I say this all the time. I'm going to get a tattoo. If I was brave enough to have a tattoo, this is what I'd have. Helping each other is the hardest job in the classroom. Right. So his point would be, okay, you finished that yourself. That's good. That's hard enough. But I'll tell you what's even harder. That's making sure your mate next to you can also do it and understands how. And the way Sammy gets this to play out, and I think this is brilliant, right? Let's imagine me and you are working together, right? And let's imagine you swatting things. You've blasted off, and I'm really struggling because I don't know what a surd is, right? And you're sat there all cocky, blah, 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 right? So what Sammy would say is your job is to help me.
Yeah.
Right? So you sit there and help me talk me through it. End of the lesson, what's Sammy going to do? He's going to ask me, he's going to say to me, okay, Craig, can you talk me through, don't just give me the answer for Jay, talk me through how you did Jay.
Yeah.
And if I can't, do you know what's going to happen? You're in trouble.
Oh, because I haven't explained it well enough.
Yeah,
because I was thinking this isn't going to work because I'm going to tell you the answers.
Exactly. Your incentives are all wrong. Whereas in Sammy's classroom, the incentives are all aligned. And if I get it right, you're getting praise.
Yay.
But if I get it wrong,
like a merit or something,
you're in trouble. So anyway, that's a little aside there. But I just think, I think this need for differentiation and providing extra challenge, I think a lot of that can be overcome if you have that kind of ethos in your classroom where it's hard doing something yourself, but it's even harder helping someone else. But anyway.
The explanation's the hard bit, as we know, because we're teachers and it's hard.
Oh, now we're talking.
Look at this.
Things are looking
terrible
up.
Website,
Things are looking up.
Mathsvens.com.
Yeah.
So lots of reasoning on all the Venn tasks on this site. And this one is a lovely Surds task. So in the top left, we've got Surds that can't be simplified. So we might have root 3 up there in A, but then we've got contains a digit 4.
That's good, this one.
And then we've got we've got contains 3 digit. Oh, that's hard.
Yeah, it's a good one. This is good one. It's good. This.
Really nice. So there's anything that's not in the green circle is something that can be simplified. I think yeah, I'd love to have a go at this task. Like loads of challenge in this. And
Do you want a couple of Venn diagram tips?
yeah,
Okay, so for viewers who don't know, this is my website, like the variation one is as well. Venn diagrams, a couple of things to make these. I love them. I've incredibly versatile and use them for lots of different things. A few little tips. So you wouldn't go near this with a barge pole. I don't even know if that's a phrase, but you wouldn't go near this. It's definitely not. Unless your kids are incredibly secure on the structure of a Venn diagram. So you
Yes,
don't want
yeah,
them thinking about what does it mean to be in region
Oh,
D.
definitely,
You
yeah.
want them thinking solely about
Yes.
so you've got to do some basic sorting activities and blah,
Yeah.
blah, blah. Final two tips. If a child finishes early, so Joe, she's whizzed through it.
Yes,
So what I'm
always.
going to say to you is I'm going to say, okay, what's the most interesting example you can think of for each of the regions?
Okay,
So
nice.
that's
Yeah.
a nice one to do.
Yeah.
And then the biggest challenge maybe with this is how do you mark it?
Yeah,
Because
oh, yeah.
everyone's got different answers,
Yeah.
blah, blah. So you can't just put answers up. So what we do is we swap, we mark each other's.
Yeah.
And we get practice of checking each other's.
Right.
And if we disagree with any, if we can't resolve it, we put a hand up and
Nice.
it becomes a whole class
Yes,
example
that's
to discuss.
lovely. Yeah.
So, yeah,
I
big fan of
used
Benna's.
your sequences one with my year 8s recently.
Yeah,
And
it's good,
actually,
aren't
because yeah, like you say, the idea of getting them to understand how the regions work, because this was the first time I'd done a Venn activity with them. So I started with the 2-circle Venn,
Yeah,
and I
it's good.
modelled it
That's
as a
good.
class, and it was like triangular numbers, prime numbers, or something like that. And we modelled it as a class, and then we tried. Then I got them to do one in their books, and then we did one that was nth terms together, just a 2-circle one, and they did one in books, which was 3-circle. And as usual, whenever I use these tasks, it's their explanations as to why certain numbers have to go in certain regions are really good. This is a great activity for developing oracy, particularly like you say there, if you think a region is impossible to convince, to fill, convince me, and then they will give some lovely explanation as to say a number can't be prime and a square or something like that. Yeah, really
lovely
nice
stuff. Lovely stuff.
I want to show you this another Dr. Austin resource. Just
She's
in
getting
terms...
a lot of feature in here, isn't she,
Well,
Dr.
she's
Austin?
fantastic.
She's good.
Yeah, we are
she
using her
is.
loads at my school. I tell you what's nice about this is it does go on to those, the ones with the binomial at the bottom, but I tell you what, it's just the scaffolding. So this is a good example of a scaffolded task where she's starting off with an example. So it's there for students to copy, like if they need that support.
It's good, that.
Then they've got what do I do on the first one? Oh, I multiply by root 3 over root 3, fill it all in. And then filling in various boxes, just nicely scaffolded and structured so they can fill it in as they go. Like, so that's if you've got students who need scaffolding, it's there. There are so many problem solving things. Look at this. This is
So where's this from?
this was someone tweeted it, so you can see the Twitter handle at the top there. I don't know. I don't know him, but he tweeted this years ago, and it's nice resource. I got a few from him on Surds.
It's good, that.
Really challenging. Like he's saying, cut it out.
It's flipping hard, that.
It's really challenging because you haven't got a starting point. It's really, really hard.
Good
so
God.
yeah, again, like you can't say there's no challenge in
No.
Surds. Like this is really tough. And he's got a couple of resources like that are just incredibly
Flipping
challenging.
heck. Yeah.
But yeah, like there's like a starting point. Like you might want to give him a starting point on that one. But
correct.
yeah.
Wow.
And then this one, it's so lovely for Maths Pad.
Go on.
So
I've
this
not
is
seen this either.
you've got a rectangle with side length
that's good.
3 root 2 and root 2. And then you want the perimeter, so then they're adding, and then you want the area, so you're multiplying. And see that, even straight away on question B, the adding is not straightforward. You need to simplify first. And then we got some working backwards, and we've got some with like binomials, expressions, and all sorts of things. So really, really lovely task. Like,
Love
really
it.
good. I wanted to zoom in on that one just to show you how hard it gets. So that was like the first bit of it.
Yeah.
But look what we've got down there. Like the area's 3 on the bottom one.
Yes.
And we've got one side length. So that's a rationalising question.
Yeah, good.
Is it rational? Yes, it is rationalising because you're doing 3 divided by...
Yeah.
The thing is, you could write the side length of y as 3 over root 7 minus 2, but then you're going to really struggle to do the perimeter. We have a reason for rationalising. Nice. Yeah, it's good.
The good Maths Pad.
The good thing about Surds is there's loads of challenge because it used to be on A level, and so you can look at old C1 stuff, and there's tons. Like these are Solomon sheets, which are always really good quality.
Yep.
Really, this is really challenging for a further maths class or a good year 11, year 10 class. So in that top one. That is rationalising again. So we're given the area, we're working backwards.
Lovely.
But there's also some nice, like quite complex adding And then look at that last one. Given that the point with this coordinates lies on this curve, that's quite tricky, isn't it? I mean, you're just substituting x and y, but yeah, you can see there's tons of challenge because it used to be on A level. There's not difficult to find challenge. And these are like just my final three. Like I love these. That top one is one of my favourite questions ever. To simplify that,
is good,
you know, just because, you know, writing that 1 plus a half is 3 over 2.
Yeah.
Once you write them all out, everything just cancels and it's just beautiful. The top right one was from Chris Smith. Really similar to them. I think maybe the Maths Tab one came out after Chris shared this in his newsletter, but his is slightly different in that you're also finding the length of the diagonal, and that's really nice. And then, and actually, I think that one might just end up with. That one just ends up with integer answers, possibly. That one from Chris Smith. I'm not sure, but without checking, but it looks like it comes with integers. And then a brilliant. That's your really high level of challenge. Really quite tricky to simplify a root of a root. That one's like a totally different level of challenge.
Anything more to say on Surds?
No, I think that is a very deep dive into Surds because we did the history and the meaning of Surds, and then we've looked at the whole curriculum and assessment, and then loads of methods, resources. There's tons there. But I think if someone's going to start teaching Surds for the first time, or someone who wants to deepen their understanding, hopefully that's been really helpful in terms of like the whole of Surds covered. In quite in a lot of depth there.
I forgot to say one of the things, as well as getting out of the way straight away, Surds rhymes with turd. The other thing I say a lot is, and I don't know why I say this, but I've always said this for 17 years or whatever, Surd alert. So if there's a Surd on the board, I go, Surd alert.
That's good. I like that.
Surd
alert.
Alert.
Because quite often it's like, oh, we have a Surd in this question. So, like,
alert.
That's nice.
So you
Surd
use
alert.
that if you want.
Yeah, I might borrow a Surd alert.
Okay.
Yeah.
Okay, so to wrap things up, just couple of things. Firstly, massive thank you for watching. Firstly, thank you to AQA for sponsoring this and making this possible. A reminder that all the resources from today are available to download for free wherever you got this video from. Check out our other Topics in Depth video. We cover loads of different things. We've been doing these for a few years now, so hopefully if you found this useful, you'll find the other topics that we've done useful. And a quick plug, both of us have got books out. Jo, Queen of Methods, as I called her earlier, has got a book, Mathematical Methods, which shows you loads of different ways and approaches of doing topics, which is problem solving in itself, because if there's 2 or 3 different ways of doing a problem, why do they come up with the same answer, which is more efficient for different uses and so on. It's absolutely fantastic book, and my book's out as well, which is Tips for Teachers. So Jo, always a pleasure. Thank you very much.